40.
You're 40%. The highest percent?
Percent 93.
No, it was the lowest percent. It was Rossi. It was Rossi.
87%.
Oh, wow.
57?
No, I really thought I got like less than that. I'm so glad if I got that.
Wait, Cindy, what'd you get?
I don't know. I thought you did the lowest score 37. I tried to voice it.
Hey, I need these back. Don't throw them away. I want them back.
I guarantee you. I really don't. I really didn't do much.
Oh my goodness. I got a 76%.
I got 20.
I got a 70.
Don't
You got a 74. I got a 94.
Okay,
what's 38 divided by 4?
Bet me right now.
What'd you get?
What'd you get?
Well,
Did you get 5 on this?
Ouch. What is it? Oh, you can do worse than me. Good job. I told you.
all right. Okay, so first, let's go over
I
test.
got an 88.
I got 90.
Okay. Hey, can somebody hit the lights for me, please? Want to make sure?
I feel like this is the worst. Are you
Cindy,
kidding me?
what'd you get? Actually?
Okay.
Actually, I left
Hey,
like.
Listen.
Okay.
I didn't like it. That's
Hey, real quick. Okay, you can see the scores out of 43. Point spread is over the side, like basically what it took to get all the full points. Okay, first you have to calculate slope. You have to subtract the y numbers, subtract the x numbers, and then the bottom turn out to be plus, and you can divide to get 2. Now, what do you have to do with that? Hey.
Shut up, Nielsen.
So, you had to plug in the slope of 2, and then you had to subtract the coordinate. Now, whatever coordinate you picked, if you picked 2, 6, if you picked the negative 1, 0, whatever coordinate you picked, this number goes in with x, that number goes in with y, or x and y. And they had to go in the right locations, and you had to be subtracting them, no matter what the number was. So if you had the negative 1, you had to subtract negative 1 and make plus. Okay, there was number 1. It was worth 3 points. You had to find slope correctly, and then you had to plug in the right 2 numbers in the right spots. And you had to at least have a form. If you didn't actually go to an equation, because maybe you didn't have time or you didn't even think about it, you just found slope and you forgot to go back, you probably missed a point or two, just because that was kind of the main point to get to that equation. Slope was just one part of it. Okay? Number 2, you had to find parallel and perpendicular. Really the only mistake that I saw somebody make that was pretty normal was plugging the numbers, like the 2 and the 1 in the wrong spot by accident, just going too quick. But usually people are finding the slope correctly, like how you're using this slope, which is 5, in the parallel one, and then the slope for perpendicular is where you do an opposite reciprocal, you flip it over and make it negative. But then you had to subtract the 2, 1 in both. I had a couple people that went further, bless you. I had a couple people that went further and actually like simplified a little bit, like distributed the 1/5, added the 1 across. That's good, that's fine. I didn't ask for that. You could have just stopped, because I didn't say what particular form I wanted it in. So you could have went to any form you wanted. Okay? All right. Number 3. Number 3. This one was pretty much the one that most people I think missed a point or 2 on.
I missed 2.
Okay, if you didn't attempt.
0.
Alright.
If you didn't attempt.
Now, hey, what you have to do, we covered this in class, you have to take the later date, divide by the former one. So these are the amounts that you're getting. So 25 divided by this. Then the formula is this one. You can use either one. Now, the reason I gave you both is that because one of the questions says find the growth rate R. This is the growth rate which we're going to find later.
Right.
Okay, so I use this one. The T is the time. That's this amount of time later. When you divide, that way the Q of A's drop out because it didn't matter the amount you had. When you get to your A, because you take top minus bottom, you get to this part. And to solve for A, you don't take the log on both sides. The reason why, you'd have a log of A left over. It doesn't cancel, it's not like in E. So you'd have to take this power to the other side and do a radical of it. Now I know that's really weird doing a radical with a decimal, right? You can write it as a fraction. We've done fractions with radicals, that was in the chapter, right? 0.03, this is just 3 over 100. You can take this power to the other side and do a reciprocal of it.
Or I just want you to know that I did that and I didn't think it looked right at all, so I erased it all. Me too.
Okay, you can do that. So that's putting the number 1 to the 100th power and taking the 3rd root of it.
I did the work.
Okay, that's just a way to simplify it. If you don't if you don't have that idea of how to type that in your calculator, where you use the 1 over, or you, where you put power like 1 over 0.03.
Did anybody get 100%?
No.
Wow.
Highest was I think 40 out of 46.
Yeah, I got the
Okay.
lowest.
Alright, now hey, okay. Now quick, when you solve, and we found it was like, when we solved for 8 it was 1.05, that's 5% growth, it's 5.4% growth. And that's the R. The reason why this number should be about 1 something. If it was 2, then that's 100% growth, not just 5.
Oh, wait, I have 105.
Okay. Alright. Let's stop talking. Okay, number 5, 6, and 7. A lot of people, when they attempted these, they had the initial idea right. The problem is, most people were using the wrong formula. Because I said, when we were going through the chapters, you need to know the difference between exponential and annual. Okay? This one requires exponential growth. It requires the E. It's basically the same formula you used up above, but you're using an E, not an A. Now the reason being is because it says in the problem you're exponentially decaying. That's not continuous like annual decay. That's a difference. Question.
So this is actually worth 7 points.
Yes.
How did I get 6 of them? I literally wrote down random stuff.
Well,
And you only took 1 off.
the random stuff was actually written correctly. So.
Nice!
Alright, so, okay, so here's the idea. What I told you is that you could put in any initial amount you wanted.
Did you realize we started one done evenly?
Yeah.
Do you like that?
Yeah, I thought it was funny.
That's
Alright.
funny, that's cool.
So, alright. Now, hey, the initial amount that I had, I just said make up a random number on test day. So I just put in 100. Just random, that's the amount of milligrams.
I put in 2.
Okay, I put in 2, fine. Whatever you have. This E is going to stay there. The R is what we're given. We're decaying by 2.4%. That's a negative 0.0247. Where most people went wrong is right here. They forgot the negative. You are decaying. That is negative growth. The time I don't know, and this is the amount. Now, that's part 1, right? The formula. Part 2 said find out what happens 100 years later. So you put in 100 for the time. You actually type this in the amount here. I just put 100 for 100%. When you decay, this number is the amount you're decaying by. It could be close. If you use the formula above, you would have been off by a few decimals. You had to use exponential growth because it's not annual growth, it's exponential. So it's 8.4% like what's left. It's 8.4 grams left, which is, so whatever amount you had, because maybe you used 2 as your initial amount, whatever number you had to take this number, divide by 100, and that was like the amount of percent you had. Okay, now, part 7 of this one was you had to figure out when would it be half-life. Half-life is if I started with 100 and I ended up with 50 on the other side. So I divide, I get half. You would take the natural log of both sides, that way this natural log of half, this drops out front, because the natural log of e cancels, and then you divide over. This is how many years it is. The people who got really close is because they used the wrong formula. They tried to use the formula from problem 3 and 4, when it was exponential growth, not annual growth. I tried to remind people of that. Okay? Alright, but it was really close. Some people are just writing some stuff down where they had logarithms. You're doing the right stuff.
I'm so proud.
It's just you had to just continue to solve it out.
You know how I got that one, Mr. Ward? That was the only formula I could remember.
I like how you misspelled the whole thing.
Yes,
I was like,
Okay.
right.
Okay, hey,
I have full point with that.
8 through 10. These you should not get wrong.
I got 3.
You should not. The reason why, this is just simple algebra 1 now.
Yes, it was.
Okay, you're plugging in a 1 into the g function. 1 in here, okay, 1 in here is 2. 1 plus 1 is 2. And then you have to plug it into the f function, 2 squared. 2 squared, which is 4. Alright, now,
Plug it into the f function.
so, okay, f of x is x squared, and then you have to plug that into the g function. So x squared is getting plugged in there, so that's x squared plus 1. That's all you're doing. You're taking out the x and you're plugging the new variable in. Okay, now, f of 2, g of 2. You had to plug in 2 in the f function, 2 into the g function, and so it's plugging in 2 here, 2 there, and then you had to multiply the 2 things together, because these are being put together, so that's being multiplied, so that's 12. Okay, it's simple, basic computational stuff. You shouldn't be overthinking it. Okay, 11 through 13. I tried to pick an easy one. I promised you I'd pick an easy one.
Thank you.
So,
You say for
For this problem
Yeah,
right here,
okay.
11, 12, and 13, you just put OK all over my paper.
oh
You
yeah.
didn't count them off, you put X's and OKs.
There was a couple that I looked at your graph and I was like, ooh, that's wrong. And I crossed out like, oh, that's bad. And then I noticed when I was to the next question, I was like, I just like, for some reason, I like glanced up at the graph again and I saw you had changed your scale. Your scale wasn't going by ones, it was going by twos.
Yeah.
So I'm like, your graph is
Yeah,
right.
you did that to me, so I did that to you.
Yeah, so your graph was right after like I glanced back, I'm like, oh my god, the graph has a different scale and it's actually correct.
No.
So I had to go back and put it.
Oh, that's so happy.
So, alright.
Mr. Johnson.
What if you
So-
wouldn't have done that? I wouldn't have caught if you got it like wrong.
Seriously.
I would just left it.
Okay. Question. Yes. Okay, now, number 11. Does this function have an inverse? No, you can see why. When you draw a line, it did hit the graph more than once on a horizontal line test, that's a fail. It's not
That's a
symmetrical because the right and left side are definitely not symmetrical to each other, they don't look alike. And this doesn't have an intercept like an x-intercept, but it does have a y. Now, my graph actually shows the y-axis. I was actually looking for the graph to show me them. I wasn't requiring it, but it does have one y-intercept, and I left this one off so you can see it. The y-intercept is a -2. So there's no x-intercepts, there's none for x-intercepts, I'm going to write that. But there is one y-intercept that is -2. So all I was looking for, if
Why
you
was it
graphed
negative
it,
1.5?
it wasn't, because the idea is that if this is my spot here, I'm moving over half,
Right, yep.
that's moving over half, and then down 2.5.
Is that exactly accurate?
So down 2.5, 1, 2.5.
And a half makes it to 1.5.
That'd be at 2.
Uh-uh.
It's at half.
Yes, okay, so do it again.
Down half and then down 1, 2.
Oh.
Gotta go down 2.5. So
I'm not good at math.
So,
Adding.
alright,
Uh-huh.
alright. Now, if your graph showed that you're having x-intercepts and y-intercepts, it's fine. But I was looking for like, is your graph scale correct? Are you at least labeling stuff? My graph, I just showed mine down there. It's definitely smaller than you think it is. Because I blew that picture up really big from what your book had.
What about you?
Okay, 14. Okay, 14. This one's pretty straightforward. The problem that people had with 14 is that you took the natural log of both sides. Most people did that. They dropped their powers out front. But then you didn't go anywhere. You had to solve for x. So what I mean by that is that when I drop the powers out front, like this then cancels out, so I'm left with an x plus 1 over here.
Yeah.
If I subtract the x over,
It
like-
cancels X's.
so, no, it doesn't. I have this. I subtract the x over.
Yeah.
And the idea is that what you would actually do is you'd factor out an x, because both of these have an x in common. And what I'm left with is a natural log of 2 minus 1. Because there's a 1 there, they both have x's.
Now what do you do?
So I factored out the number, and then just divide by this. This is just a digit. It's just a number. You can type in your calculator, get a decimal.
I know that the X's.
And you divide it over. You can see on my paper there what I did. I didn't show this step where I subtracted it over.
I thought the X's didn't cancel.
No, because this one's just a number. It's like a 1.7x. So that's a natural log of 2 is like natural, it's like 1.7.
No,
So that's 1.7x, and then I have 1x, well, subtract over is like 0.7. So then I can divide that number over. Because they're just leading coefficients, they're just different numbers. If you actually wrote decimals down, because a lot of people were just writing decimals. Okay, the next one. Divide the 50 over. Take the log of both sides, not the natural log. That way the power drops out, and you have to divide by this number over. You could have left it like that, or you could have wrote down the number as -23. But I was looking for that. It was negative, for sure. Because you are decaying, so the process had to
You
actually
are
have to be negative.
decaying.
That
Okay,
made no sense to me at all.
alright, next one.
I'm just trying to get
Why did I get 52 as funny?
I tried so hard on this one, Michael,
Alright.
and you still counted it wrong.
Yep.
Yeah, did you know how much I was stressing? I kept asking you, like, come here.
Points off on it.
But no, look, I only got 1 point off, so it's okay.
Okay, hey, how I graded this one, as normal. I was looking, did you have your amplitude correct? Was it 8 above the middle and below the middle? Okay, you had to have your middle correct. You were shifting down 4. So you can actually see, I'm starting at -4, I'm going 8 above that, 8 below that. That's what I'm looking for. Does your graph look like a cosine? You got a point for that.
A cost?
Then, the problem was, did you shift it right and left correctly? I was looking for, did you at least shift it over to -half? If you did, you're good. You at least got a point there. But the problem was, it wasn't just shifting over to the negative
The
half.
spaces are
It was
different.
the spaces were weird. Because you're starting at negative half right here, so like zero's up
Wait, but
here
don't you have to
somewhere.
bring it left or
But-
right?
We moved it to the right half, but the problem was, your spacing to the markers is weird. Like 0, 0 is right
Okay,
here
okay,
for
okay, I
me.
see that, yeah.
Like there's 0, 0. So the idea is that how did I get to this part right here? Okay, how did I get to like these 4 hash marks? My normal graph, my normal graph goes out to 2 pi. But what I did is I divided by 2, because that was the number in front of x. So my graph is technically going to go out to pi if I didn't have to shift it right and left. So I divided by 2, divided by 2 again. This is the spacing that I would normally go if I didn't shift it right or
So
left.
I have a question, so I added those, so why didn't it work?
So you had to take your starting point and add what that spacing was.
Oh my gosh, I
Oh,
actually did that, you
I
counted it wrong.
subtract.
But you had to get them correct to get the right
So I didn't know
decimal.
what to
People
do.
weren't getting the right numbers because they were just adding those together
From pi.
and they were saying, oh, it's negative 3 or negative 3 in pi. That's not correct. And there was just weird numbers. The numbers I'm actually getting when I actually add all of these together are these decimals here.
So you're telling me
And
I
what-
should use decimals instead
Well,
of
no, no,
trying
no,
to-
because whatever you guys had written, I would type it in a calculator to see if it was the right decimal. And if it wasn't, I counted it wrong.
Yeah, but you probably got wrong when you tried to solve with all the pies and stuff.
So, some parts go off.
That's
Okay. It was just, you had to figure out your starting point, and then you had to add that spacing. The hardest part for most people is figuring out this spacing to start with. They don't know how to do it. You ignore the 1 to figure out the spacing, because the 1 is shifting it right and left. This 2 affects the spaces. So you had to divide 2 pi by 2, that's your marker, cut in half, that's your spacing. That first marker tells you how far you're going from the first spot, which is negative half.
So
Okay.
anyway, pass or fail?
Definitely that. Alright,
No, I'm
So-
really not.
alright. I'm gonna walk around, I'm gonna collect my tests.
If this were passed,
You do need your notes out. We're just gonna take a few
Wait, I
notes
can't
today,
keep
and then we're done.
this?
Nope, they're mine.
Mr. Lord,
I always take them.
this where you found our results.
I'll be here 7:30.
I won't.
You never take them back. We always used to get to keep our tabs.
Do we get till Friday or Monday?
You have a week from today, if you're
From
gonna read.
today?
So Monday is a better day because Friday's homecoming week.
Or do you think that there's a way
Friday is
that-
midget week. What?
How long do you recommend I come in? Like how many days and how long time?
I would say as soon as possible is the
Don't
best.
Mr. What that I look a lot like.
Because you'll start
Like,
forgetting stuff as we go to the
You mean like
next.
7:30 a.m.?
Oh, no, I'm saying like, come in the next couple days.
I'm gonna, but I don't know what time to come.
Some
Mr. Ward.
7:50. Give yourself 10 minutes to go over review.
Mr. Ward.
7:50?
I feel like I might come in, yeah, tomorrow and Wednesday and then do
Have you
it.
ever seen Khalil Mack?
That's how I'm gonna do.
Khalil Mack, an NFL player. He's
I don't know stuff, like, it's not something, not, it's like not.
Actually, I can see why not.
To see a wide
I'm
receiver.
telling you this right now.
No. Yeah.
But he's a defensive end.
I was seven.
No, like we look a lot alike. No, look him up, Mr. Ward.
What's up?
Wednesday, Thursday are most of the days. It's so crazy. All it is like, what are you learning from the speeches? What are you gonna learn?
Like what?
Any questions?
All right. Okay. Hey, eventually you will get to keep this. It's just that right now I just want these back for helping out if people are going to retake. Now, hey, same policy as always. You can always retake any test. Doesn't matter if you pass or fail. If you definitely failed, you have to retake it. So you have to come in here and spend a minimum 10 minutes with me. You always get the better of the 2 scores, but I want it done within a week. Because that way you're not forgetting stuff and we're moving on to the next couple sections. So it's kind of a no-risk answer, okay? But again, it will be a different test. I'll have different numbers. I'll pick problems from the homework again, throw them in there, and you can see how they work. Okay?
Hey, since Wednesday is a short day, if I came in 9th period, do I get like 5 or 10 minutes into the
Hey, wanna retake it with me? I'll do it.
Can I do that too?
Hey, it's Thursday.
Okay, all right. So,
You take it better than 2 scores?
always. No,
We can do it.
I'd rather have you get a good
I'm
score
gonna have some
than
to take all in all.
Okay. All right. Hey, we're gonna take a few notes today. You definitely will want,
You're going to see
you're gonna definitely want your notes out right now. The problem we're gonna talk about is something that we've done in pre-calc, but today's a review of it. Okay, so take it out right now.
How hard?
Give me a
Take it
second.
out right now.
Do we need our calculator?
What?
Okay, I'm turning it off. Tyler, shut up.
About the same as pre-calc.
I heard that.
I'm sorry, you weren't.
I'm offended, I'm offended.
It was an inside
The
joke
chapters
here.
traditionally get harder.
I look on it, so.
My apologies. I'm sorry for
This is,
your,
I would say it's pretty similar.
I swear to God.
Does it sound like a charge?
sorry for your.
Hey,
Let's
Lord,
hold on to-
I look a lot like Leo.
Stop being excessive.
Well, look at what
Maybe
I'm
let's put it in my mouth. 'Cause
Why?
I'm too lazy to like.
For class though, I'm just gonna show you what Leo not looks like. I actually look a lot, I think I look like my play style is very similar to yours. We were playing 2 touch football today before I had 5 seconds.
Oh, yeah.
I did. Shoot neck? You know who shoot neck is? Caden?
What chapter is this?
Yeah. I said, was he saying about how smart he was?
Not like I took chapter 1 though. Hey, it's chapter 3.
What?
It's chapter 3. I hate it when I watch.
Chapter 2.
I thought that one was 1 and 2
Close. Alright. Okay, alright. Hey, now, this is gonna seem weird. We're moving on to chapter 2. Okay, but here's, we're moving on to chapter 2, but the section we're in right now is technically 1.6.
1.6.
Now, I'm mixing 1.6 and 1.7 into chapter 2 because it was a lead into what you need to know for chapter 2. So I didn't put it in the last chapter test because it was so much different. Okay? Because what we're going to next is graphing, like polynomials and slope and other things. So this section's about graphing in the first place. Okay, so.
About how I went to walk back to next door.
Not really what.
Yes, I'm not kidding. Lord, I wrote my comp times writing all
Yeah, I
this
think
class.
it's 700 yards off of 200 pages.
Wait, no! What do you mean, guys? I wrote my paper in comp about this class.
Oh, I thought you said you wrote your comp paper in this class.
Right.
No, I wrote it about this class
Okay.
because it said something about negative attitude. I said I went into Ward's room with a positive attitude and still failed the test. I literally put
That was
that.
your writing
Life
thing?
sometimes
Yeah,
happens.
that was my time writing. I said I went in with a positive attitude. I failed the test, but at least I had a positive attitude.
You did.
Did you use the John Wooden quote?
I did what?
Did you use the John Wooden quote or what?
The cactus one?
Oh, the
that's
cactus
Joyce.
one.
You know what you should have wrote about?
Yeah, but cactus, that's Joyce Meyer Shire's quote.
I used
Alright.
the John Wooden.
Hey. Okay, real quick. I'd like you to write this problem down. This is our one problem that I want to do today. It's just, we're going to do one problem to talk about this section we're going into. Today's a light introduction to what I want to do. Okay?
Light introduction?
Light introduction.
That's a big
No.
introduction.
So,
No.
alright. Now, hey,
Don't go on yet.
chapter 2 is about graphing. It's about graphing derivatives. It's about graphing slope, which is it's about which we're gonna get into. We're doing a lot of different things. Hey, let's stop talking right now. I'm over it.
What?
Stop. So, we're gonna be going through and we're gonna be learning pretty much some pretty heavy calculus now, which isn't difficult. It's just that it's your first starting point into it. So we gotta get the basics for graphing, because that's gonna be a big piece of like multiple sections in a row, is they'll take little pieces and say, hey, graph this. So, I'm starting with this problem. This is something we did in pre-calc, but the reason I'm bringing this problem up is just so that we have that basics of what we did in pre-calc and what we're going to apply to it, if that makes sense.
So is this chapter 2 then?
This is technically chapter 2. It's graphing, chapter 2, but I have a couple sections mixed in. Alright, now, the section we're talking about is graphing. So what I want to be able to do is graph a polynomial. So the idea is that we have to look at end behavior. That was one of the big things that we had. We have to look at the intercepts. The intercepts, so there's x and y intercepts. We have to look at both, which are called, the x-intercepts are called zeros, or roots, if you will. Then what we're going to look at is something that we did in pre-calc, which I don't know if a lot of people understood it, was this idea of when it changes from like a positive graph to negative, when it like oscillates up and down, it's the number of switches that the graph goes up and down. So it's actually what we called it in pre-calc is we called it turning points.
Oh, and behavior, are they the same ends because it's a 4? Is there a 4?
Yeah, so that's something we're going to look at.
And it turns 3 times?
It will.
Oh my gosh, I remember that.
Yes, so there's a little bit of things we did in pre-calc. So today was just to talk about those little things. Okay? after we're all done, we'll look at, we can look at if there's any, intercepts, or if there's any intercepts like horizontal and vertical, if it was a split. But this is like the start today. This is what I want to get covered. Okay, so I'm going to put a graph up on the board.
Someone should start doing the close quotes with these.
Okay. Shh.
Class 1.
Oh my gosh, I'm so happy with this.
Shut up, please.
Will you shut up, please? I want to get through this stuff. You guys keep talking every time I stop. So, what I want to cover first is end behavior, the tails. So, end behavior and the tails, and if we know if it's symmetric or not, that's a part of end behavior. We already said, Reese already said that since this is a power of 4, it's an even power, right? It's a power of 4, it's called the quartic function, it has power of 4. If it's an even power, the tails, so this is even power, for the biggest power, at least the highest degree, the tails are going to go the same direction. Tails end in the same direction. So what I mean by that is that we're looking at, are they going up, are they going down, that type of thing. And what gives that away is the power, number one, saying that they're going the same direction since it's an even power function. That's the power of 4. And the next is you look at the digit out front, which we call the leading coefficient. The leading coefficient is that digit out front of your highest term. So that's this number right here, which in our case is a 1. Since it's a positive number, the tails are going up because they're going the same direction and it's a positive number. This leading coefficient was positive. It's a positive number. So that means the tails go up. So we're going up at the tail. So I know that the end behavior somewhere, somehow,
Up there.
this is what's happening.
Boom.
The tails are going the same direction. I don't know where, but on the very ends of this graph, it's going up. Now, the next thing we look at, after we look at the tails, because that was a very generic way to do it,
Oh, the intercepts.
we look at intercepts. And then after that, and this is a part of this end behavior on the intercepts, we look at, is it symmetrical? Is it like perfectly balanced over the axis? That was something we had in the last chapter, talking about is it symmetrical or not.
No.
So we have a little rule for that, which we did in the last section, which was part of graphing. But in this case, how do we figure out intercepts? The y-intercept is one of the easiest. Plug in a bunch of zeros for x's. So to find a y-intercept, you take your function and you plug 0 into all the x's. So yeah, we're going to get a bunch of zeros, except for the 60. 4, 3, 2, 1, 0, and there's all the zeros when I plug them in. Like that's a 0, 0, 0, 0. They're all being added together, plus 60. So I'm going to hit 60 on the graph. And let's just say 60 is here. We'll just put a new dot. We'll put a new scale to it. So that's 60 for some reason. I just picked a random. Okay, so that's my y-intercept. So I know that somehow, some way, it's going to cross through 60. Because again, I plugged in zeros into all the x's. Okay, does everyone understand intercepts? Now, the x-intercept is the more difficult one. The x-intercept is where you try to factor things apart. This thing's a monster. It's big, right? So we don't have the luxury of doing like grouping method or anything like that. So what we have is this little rule where you can check numbers that would possibly go into this. It was called synthetic division, where we checked to see if it works. Now, we're just going to use synthetic substitution, where you just use a character type and hit enter. And it just tells you either yes or no. So what I mean by that is to check what the actual intercepts are, the x-intercepts.
I am.
You take the back number. So, we're looking at the back number. You're going to look at the front number, and you're going to divide them.
60.
60 over 1, right? Back number over front number. And what you do is you break up the 60 into all the numbers that multiply to give you 60. Every combination, all the factors. 1 and 60, 5 and 12,
2 and 30.
2 and
2 and
30.
10.
I'm going in no order.
120 and 0.4.
Oh, 6 and 10.
4 and 15, 6 and 10. I'm just making any possible combination
10 and
possible. Okay, so everyone understand all those different numbers? Like where they're coming from. All the numbers I multiply give you 60. Same thing with the number 1 You break up the 1, well 1 is just,
Forgot 14
okay?
and 4.0.
And you can make every combination. So what I mean by that is 1 over 1, 5 over 1,
Wait, and the one you got
2
from
over
the
1.
X
That's
plus
just-
power?
yeah.
From the
So it's the
leading
front and the
coefficient?
back number. Yep.
And that, what does this mean?
This is how I'm gonna find my x-intercepts when we have like a monster of a problem.
Monster.
When I can't possibly just factor this thing apart.
We have to guess and check.
No, we're not gonna guess and check like doing synthetic division.
What is the last number called when it doesn't have like an X on it?
The constant? Okay,
The leading coefficient.
No, that's the first number.
constant is the
I
back
don't feel
number.
like it's called that, but.
The zero
The
term?
intercepts.
Like the verb, the consonant?
Is that a monster?
Okay, now, we have a bunch of numbers there, right? We have 1, 5, 2, 30, 12, 16, 4, 15, 6, and 10, and we have others, we have like 3 and 20, I didn't even put that, 3 and 20.
What are those called, the factors of it?
Yeah, 3 and 20. Alright, so we have a bunch, and they're all plus minus now. I don't want to type these in, I don't want to do synthetic division. So the trick is, what I would do is I would take one of these numbers one at a time. I'll start with all the positives, like let's say the number 5. I'd plug it into this problem, into all the x's on the calculators, plug in a 5, hit enter, and it gives me 0. That means it's hitting the x-axis right there. The y number is 0, so that means it's hitting the x-axis. Well, I can tell you right now, I typed some of these in earlier today because this is a problem I made up. -5 was one of them. So, -5 for sure. When I type -5 into this problem, put -5 here to the 4th, -5 to the 3rd, times 4, -5, because that was one of my options. It definitely gave me 0. That's an x-intercept. So -5.
Then you synthetically divide, and then you get a
Okay.
smaller one.
Yeah, but I would just keep going because I know the rest of the numbers are probably here. So I kept going. One of my other numbers was the number 2. The number 2 worked, positive 2.
Will this happen when we're on the test, like we just need to do?
No, you'll have to tie it out, and I won't give you something with like 20 of them. I'll give you like the number 12 in the back. So then you only have a few numbers to check.
That's like 4 and 3.
Yeah, but it's better
24
than
and
it's better than 10 or 12
Yeah,
different
what
numbers.
about 24.5? Would that work out or no?
20 like use halves, decimals.
Wait, what about
Those are
7?
the
What
options.
about 7?
What about,
Third.
for 60, what if we used 182 and 3.03 repeating?
Sure.
What about, we used 140?
-3.
What if you did
Okay,
1.9?
all right. Here's the idea. Here's the numbers I know that work.
7.
So -3.
Only 7, 1.
Oh, -3. Right there. Okay. Now, if you were to do it by plugging in these numbers, these are the numbers that work. But here's the weird thing: if you were to synthetic divide them out, you would actually find them without having to plug them all back in. Okay. So it is kind of an easier process. Now, why I'm doing this is because of what happens here on these particular problems. That when you actually plug these numbers in, it'll actually cross the x-axis there. So this is what's happening. It's crossing the x-axis.
Turn.
It's turning somewhere, coming back through.
Turning.
It's probably going through the 60, coming back down, and now the arrow's going up, right? So I'm not coming back through the x-axis again, because there would have been another number down the road. This is my last x-intercept, so probably what happened, it bounced off of this number and went back up again. It can do that. It just had to touch the x-axis there. Now, what would give that away is if we were to factor this monster apart,
There's only 3
this
groups.
is what it ended up with.
X,
Okay, that number was one of the numbers that worked.
X minus
X plus 3 was one of the numbers, and X plus 2. Minus 2. But what happened if you actually factor these out one at a time, there was another one which was an X minus 2. There was another one. So if you actually factor them out piece by piece, X minus 2 happened twice.
So it's
And
not a
why?
function.
Why it happened twice
Because it went through it twice.
is because it bounced. This is called a multiplicity. That when you factor out numbers that worked out of this problem, these are the numbers that worked. I was ending up with the 4th one because I know there was 4 roots to this problem. The highest degree is 4.
Oh.
And if one of the numbers repeated, this is called a double root in algebra 2.
Yeah, that makes like,
And what a double root is it bounces off of that number when you're graphing. This is how I found x-intercepts. Now, how I did this so quickly is I plugged these numbers in on the calculator and just hit enter until I found one that worked. So -5 worked, and so what I did is I divided it out.
How'd you know that X minus 2 was gonna be the lower
These were all the stages.
Because I actually divided these out. I was actually dividing. So I was like doing synthetic division, where I put like -5 in the little house and I wrote all the numbers. And I divided out what was left. I tried to break that. Yeah, we're gonna do that next time. Today is just intro,
No.
tomorrow.
So you're just telling us that we found it?
Yes. So, today is just a quick intro.
What are the odds that you give us a prime number for that last one test?
Like the prime, I'm not gonna do that. It'll be a number like 12, or just something where there's just a few factors.
It'd be like 23.
No.
But then we could use,
Wait, are we done?
Okay,
we
no,
could use
no, hold on.
46 and 45.
Okay, what we're doing here, the reason why I brought this problem up, you can actually see all the parts here. It has end behavior, it has intercepts, but the main thing why I brought this problem up is the turning points, and that's why I actually highlighted it in a different color. The turning points is the biggest thing about what we're learning in this chapter. This chapter 2 is all about this. It's all about finding those points of where it's called an inflection point, where it turned directions. How to find it is one of the things we're doing, okay? So the goal in this chapter, which I hinted at in pre-calc, was to find how tall these points were. The min, max, absolute min and max, that type of thing. The relative min and max. Okay, does everyone understand what we're going to be trying to learn in this chapter?
Yes.
Okay, if you have not already, I would like you to write this problem down. Try to draw the rough graph of it, just rough graph, no grid paper, and circle the points of what we need to learn before we exit this chapter.
I actually took notes today.
Good. Today was a light intro day. Like, I know that seemed like crazy, but we're going to be learning these parts as we go. Okay?
Are these in a grade book, like, or the test?
Yeah, the test will be in today. I'm just going to plug them in. I was waiting.
Can you do mine so I can see what my grades out in this class?
On the scale of 6 to 10.
It's literally gonna be like a zero, is that the thing? Like,
You're gonna show us your work.
You know what fix it right? You know what fix it once grades this class?
if we did have that test,
If we made it
I
pass
agree.
Is it
fail.
gonna
If we made it
come
pass
back to
fail.
haunt me if I
I
don't?
gotta put my hair out, I can't.
Yeah.
See, if it was pass fail, I wouldn't be retaking this.
When you say right now,
Wait, does this class look towards our GK?
Yeah.
Yes, it not.
Are you kidding?
That's it.
Is that, like, let's go?
Yeah, I know, I've been trying to do it. No, it was supposed to be pass or fail. I think it was because of our
Mr. Warren, look up Khalil Mack.
Does
Isn't that the
does comp
funniest
code
Yeah.
use our high school?
Honestly, though,
No.
I honestly think I'm like
That's right. I was like 83.
Comp?
Why do you want to pull the
No, you know what's?
Well, this is Abby Sokol gave me this, like, hey, you can wear a wine shirt. I got one in my locker.
Like,
All
my
right.
college class is getting like good grades.
Oh, I